optimization. What is optimization? Well, optimization is what it sounds like, optimizing. So when you are optimizing something, you are getting the best result that you can. So when we're looking at optimization, we're looking at getting the best result. And by best result, sometimes that would mean the maximum. Sometimes it would mean a minimum. It just depends on the question and it depends on what we're looking for. Depending on the situation, we could be looking for a maximum. In another situation, we could be looking for a minimum. So when we're looking at optimization, we're looking at finding the maximum and minimum values within given constraints. So how do we solve an optimization question? Well, I wrote a few steps here for you in case that helps you to guide your thought process. These steps are very, very similar to the steps we used when we were solving related rate types questions. So the first step is to read the question. We need to make sure that we read it. We need to make sure we understand. We need to make sure that we know the situation that we're dealing with, what we're looking for, and the different information that we've been given. If you can draw a diagram, it's helpful to draw a diagram, I think, because it helps to visualize and relate the information together. Sometimes from the diagram, we can see what formula we need, or we can see different ways different pieces of information are related. Assign variables. Sometimes there's some open interpretation for the variables. Sometimes it is assigned based on particular parameters of the question. Just read the question and see what you can find out from the question about assigning your variables. Then we need to look at how our variables, our diagram, our given information can all come together so that we can write an equation. And once we have an equation, we need to simplify and solve. We always need to make sure we check the domain. Sometimes we'll get more than one possible answer. Sometimes both will be within the domain. Sometimes one or the other will be within the domain. And sometimes neither will be within the domain. So we always need to check and see, based on the parameters we're given, if the answers work. And we need to make sure we're checking both the domain and the situation of the question. And then finally, check your solution. Does it make sense? Does it seem reasonable? Does it seem logical within the parameters that you were given? And give your solution a quick check and make sure that it seems reasonable. So let's try this. Let's see if we can work through this optimization question to understand what we are trying to find. So here we go. Find the dimensions of a rectangle with a perimeter of 100 meters whose area is as large as possible. So a lot of different situations here. Maybe you're building a garden and you have 100 meters of fencing. Maybe you have 100 meters of wood and you're trying to enclose a playground area. So there's a couple different reasons why we would have 100 meters for a perimeter and we would try to enclose an area as large as possible. So I just came up with the first two that came off the top of my head. But in this case, we don't have a whole lot of information about the exact parameters of the question. We don't know, are we building a playground? We don't know, are we fencing in a dog pen? It doesn't matter. What we do know is we have the perimeter of 100 meters and we want the area to be as large as possible. So that means that we are maximizing area. So step one was to read the question. We did that. Step two, let's draw a diagram. So when we draw a diagram, I'm just going to make it a basic diagram. We know it's a rectangle because it says a rectangle. We know we have perimeter of 100. So for my rectangle, this will be Y, this will be X, Y and X. And I know that I can figure out the perimeter by adding all the sides. So 2X plus 2Y. And we know that we have 100 for our total perimeter right here. I could factor out a 2, so I have X plus Y with the 2 factored out. Divide both sides by 2, and I have 50 equals X plus Y. So what we've done so far is we've written an equation relating the information that we've been given. But it says whose area is as large as possible. That means that we're trying to maximize area. So now I need to figure out an equation for the area of this rectangle. Well, area is length times width. So in this case, that would be x times y. So we have two different equations here, and we have a few unknowns that we're trying to solve for. Well, I can't really solve it as it is right now because I have more unknowns than I have equations. But something that we can do is solve over here. Let's see if we solve this for y. Let's subtract our x from both sides. So 50 minus x equals y. Now I can substitute that over here and I can get rid of one of my variables. So x times 50 minus x. There we go. Now, if you're thinking back to the related rates and you're thinking, well, why didn't we just do the dA dt? Well, the problem is with the related rates, you had a change in some value over time, like the area was increasing or the volume was increasing or the distance was increasing or decreasing. There was some rate of change. Here, this is stagnant. There is no rate of change. So that dt isn't going to help us out because there's no rates of change. So these are just basic questions that we could have solved with algebra, but we're going to solve it with some calculus instead. So if we try to solve this down, well, let's see here. If I distribute my x, I'll get 50x minus x squared. So then I can take my derivative and not worry about the product rule. So the derivative would look like the derivative of 50x is just 50. And the derivative of x squared is 2x. So if we're trying to find a max or a min, we take our derivative, we set it equal to 0. That's part of our simplify and solve step. We take our derivative, we set it equal to 0, and we solve. That's how we find a max or a min. So that means if we keep going over here, it'll look like 50 equals 2x, which would mean x is 25. So what did we figure out? Well, we figured out so far that x is 25. So this dimension for the top and the bottom of our fenced in area is 25. So now we need to figure out the y value. Well, if you remember, back at the beginning, we were given from right here, our perimeter is 2x plus 2y. And even more so than that, we know our perimeter is 100. So if we figured out that x is 25, let's put it all in. 100 equals 2 times 25 plus 2y. 2 times 25 is 50. Subtract 50 from both sides. So subtract 50, we get 50 equals 2y. Divide both sides by 2, and we get 25 equaling y. So in this case, it looks like it's a square. We have 25 meters for y, and we have 25 meters for x. So when our rectangle is actually a square, with each side being 25 meters, then we will have the largest possible area. Now, in this case, it doesn't ask us what is the largest area. It just is asking us to find the dimensions when you would have the largest area. If it asked you to find the largest area, then you would just use your x and your y, put them back into your area formula, and multiply to get the area. In this case, it didn't ask us for that, so we're okay. Let's try another one. A farmer wants to build a garden along a river and enclose the garden on the non-river sides with 500 feet of fencing. What is the area of the largest pen he can build? All right, so we read our problem. Let's see if we can figure out some of our given information so that we can draw a picture. So let's see here. Let's read it again and let's see if we can figure out and find some of our given information. A farmer wants to build a garden along a river and enclose the garden on the non-river sides. See that? On the non-river sides with 500 feet of fencing. Okay, so it sounds like we're going to have a river and then we're building a fence like this. And on the non-river sides, we're going to put our fencing. So I'll call these Y, I'll call this X. It doesn't need a fence along the river, so it says on the non-river sides. So this is just the pieces that we have to work with. So we have perimeter again. What is the area of the largest pen he can build? And to our perimeter, we are relating it to area again. So let's see if we can do this. So for this one, our perimeter is not 2x and 2y because we don't have a fence on this side. So our perimeter is just x plus 2y. See, we have y plus x. So x plus 2y. Well, this one I think would be a little bit easier to solve for x because it's already almost by itself. So the perimeter is 500. If we subtract 2y from both sides, then we have it solved for x. So now we can use our area formula because after all, it says what is the area of the largest pen he can build. So here we go. Area is length times width. The area doesn't change by the fact that it's along the river. It's still length times width to figure out area. Now this time we know that x is 500 minus 2y. There we go. So we can plug that in. I'm going to distribute that y again so that I don't have to use the product rule when I take the derivative. So 500y minus 2y squared. So then we take our derivative because we're trying to find a maximum. So whenever we're trying to find a maximum, we use our derivative. And we take that derivative and we set it equal to 0. So now we're at 0 equals 500 minus 4y. So if we subtract 500 from both sides, and we divide both sides by our -4, looks like we get 125 and it's feet for y. All right, so we found out part of it. We found out that y equals 125 feet. Well, it's asking us what is the largest pen. It's not asking us for the dimensions anymore. The first question asked us for dimensions. This one's asking us what is the largest. So we got to keep going. So next we need to figure out x. Well, we have a little bit of information. We don't have the information on the area, so we can't put it back into this equation. We do have the information on the perimeter, so we can put it back into the perimeter equation. So going back to our perimeter equation, that'll look like 500 equals x, which we don't know, plus 2 times y, which is 125. So that'll give us 500 equals x plus 2 times 125 is 250. Subtract 250 from both sides, and it looks like we get 250 for x. So 250 feet. So this means that our area is 250 feet by 125 feet. But that's not what it's asking us. It's not asking us for the dimensions. This time it's asking us what is the area of the largest possible pen. So we need to go one step farther, and now we need to find our area. So area is length times width. So we need to find our area. We figured out our length is 125. Whoops, that's actually our width. It won't matter when we do the multiplication, but I'll switch it so it's in the same order. So our length right here was our x. See, that's the long side, so 250. And our width, we called that y before, so we'll do our 125. So if we multiply these together, we have our 250 times our 125, and that gives us 31,250 feet squared. So that is going to be the area of the largest possible pen that we can build using the river as one side and then enclosing on 3 other sides with 500 feet of fencing. Let's try one more. A farmer with 750 feet of fencing wants to enclose a rectangular area and divide it into 4 pens with fencing parallel to one side of the rectangle. What is the largest possible total area of the 4 pens? All right, so let's read that again and let's see if we can draw ourselves a picture. A farmer with 750 feet of fencing. So that sounds like a perimeter question again. Wants to enclose a rectangular area. So here's my rectangular area. And divide it into 4 pens with fencing parallel to one side of the rectangle. So we want to divide this into 4 pens. Now, fencing parallel to one side of the rectangle, you could have drawn it this way instead and made your fencing go this way. And that would have been fine as well. As you solve it down through, you'll get the dimensions that will be your maximum for your maximum total area of all 4 pens. So it would be okay to have either way, because essentially what would happen is your pen would just be rotated. You'll find out the length and the width, and then the orientation of the pen would come in as you are solving it down. So for example, here I might get X as 5, and then for the one that I had drawn before, you might get Y as 5, and that's okay. We'll end up with the same basic pen, it just one could be rotated from the other. So here we go. What is the largest possible total area of the 4 pens? So here we go. Now the tricky part with this one is you have that 750 feet of fencing, and that is not just the perimeter now. That's also these extra 3 pieces in the middle, because that's what's going to split it into the 4 pens. So now instead of just saying that 2x plus 2y or 2y plus 1x or something like that for your perimeter, now we have the perimeter, but we also have these 3 extra pieces. So when I go through and label these, I'm calling the verticals y. So all of these extra pieces, they would also be y. And then we would have x for the top and for the bottom. So what does this look like? Well, let's see here. We have 1, 2, 3, 4, 5 y's. We have 2 x's. And all of that is going to be built from our 750 feet of fencing. I don't need the feet in the equation, so there we go. So now I need to figure out what else we have. What is the largest possible total area? So I'm trying to relate this back to area again. So area is length times width. So in this case, we have it labeled already, and we have x times y. So area is x times y. All right, so in order to solve it down, I need to solve this for either x or y. Neither one is real great. I think I'd rather have a denominator of 2 than 5, so I'm going to solve it for x. So that'll look like 2x equals 750 minus 5y, because we can subtract the 5y from both sides. And then if we divide both sides by 2, that'll look like 750 minus 5y all over 2. I'm not sure if it cleans it up a lot, but it makes me feel like I've made progress, so I'll simplify it down. 750 divided by 2 is 375. I can't really do anything to 5 halves, so I'll just leave it as 5 halves and y. There we go. All right, let's figure out our area. Area is length times width. Well, I figured out x. We're calling x 375 minus 5 over 2y. And then we have y. I don't want to use the product rule, so I'm going to distribute this y to both pieces. So that'll look like 375y minus 5 over 2y squared. All right, now we need our derivative. The derivative of 375y is 375. And then bring down your power here, and that thankfully cancels out our denominator, so we get just 5y. Take the derivative, set it equal to 0. Subtract your 375 from both sides. Divide both sides by -5. And it looks like we get a y value of 75, and I'll put a feet on there. Well, if y is 75, what is x? Let's see if we can figure it out. I always like to go back to the original or close to the original when I am solving for another piece. Partly, I feel like if I made a mistake and I go back to the original, hopefully I'll catch it. Partly, I feel like I know that I had a solid equation there and I don't want to work with a fraction right here. So I'll put this back into our original equation. And we can solve it for x. So we have 5 times, we figured out y was 75, plus 2x is equal to 750. So 5 times 75, that gives us 375. So if we subtract 375 from both sides, we get 2x is equal to 375. And then divide both sides by 2, and we get x is equal to 187.5. Well, that's great and all, but we're still not done. What is the largest possible total area? So now we have our x, and now we have our y. So we need to put those together, and we need to solve for the area. So area equals x times y. So area equals x, we had 187.5, times y, we have 75. So if we multiply these together, we have 14062.5, and that'll be feet squared. So now we have found our area. So now we know that if we want to make a pen that looks like this, it should be 75 feet, in this case wide, and it should be 187.5 feet long, and then we'll have enough of our fencing to put the divisions in the middle to create the 4 separate pens.